Determine the limit by interpreting it as the definition of the derivative. Limit is h goes to 0 of 1 over 2 times 3 plus h squared minus 3 times 3 plus h minus 1 over 9, all divided by h. This limit here is of the form limit as h goes to 0 of f of a plus h minus f of a all over h. Since this is the definition of the derivative, it's equal to the derivative f prime evaluated at a. So instead of working out the limit directly, we can, as an alternative, work out the derivative of f of x and then evaluate that at a. In order to work out the derivative of f of x, we have to first determine f of x. And that's determined by comparing f of a plus h to the f of a plus h term here. The negative 1/9 is the minus f of a, and we are not comparing it to that at all. F of a plus h. Now, that is f of a plus h. What we want is f of x, and that is found by taking the a plus h's and replacing the a plus h's with x's. So take this out here and put an x in its place. Take this out here and put an x in its place. And this will be your f of x. So f of x will be 1 over 2x squared minus 3x. The other thing we need to determine is a. And a is determined by comparing whatever's added to h, a plus h, whatever's added to h over here, and we can see they will match, but it is a 3 being added to h, so a is a 3. The next thing we need to do is evaluate the derivative of f of x, but before we do that, let's rewrite this. Since the numerator is just a constant, there's no need for the quotient rule, and instead we can bring that entire expression from the denominator up to the numerator as a negative exponent, negative first power. And therefore our derivative will be a power rule. To start things off, let's bring down the negative 1, leave the inside alone, subtract 1 from the exponent, and then multiply by the derivative of the inside to complete the chain rule. Before we evaluate this, let's rewrite it. That negative exponent can move back to the denominator. The negative 1 stays in the numerator, and the 4x minus 3 also stays in the numerator. And the 2x squared minus 3x will move to the denominator to become a positive exponent squared. We can now evaluate this at a equals 3. So f prime of 3 will be the negative of 4 times 3 minus 3 all over 2 times 3 squared minus 3 times 3, and that entire thing squared. So in the numerator we have 4 times 3, which is 12, minus 3. And in the denominator we have 2 times 3 squared, which is a 9, minus a 3 times a 3, which is a 9 squared. In the numerator, 12 minus 3 will be a 9. The negative is multiplying that. In the denominator we have 2 times 9, which is 18, minus 9, and then squared. So we have a negative 9 over 9 squared. Instead of squaring out that 9, we have a 9 in the numerator and a 9 in the denominator. We can cancel those, leaving us a 1 with the negative in the numerator. And so we end up with negative 1 over 9. And that is the result of this limit here. This equals to negative 1 over 9.